You didn't really think we were going to start the video with the drive, did you? Come on, we got a lot of work to do. Well, okay, before we mount the engine, I want to take care of one thing first. There's a little plug here. This plug closes off the coolant passages, and I want to put a coolant sensor there because that's where it was on the engine we took out. Something tells me this will be easier to remove before we put the engine in the truck. And I'm pretty confident in that assumption because I've already rounded off the square drive, attempted to drill a hole through the center of it, and broken an extractor bit. So let's break out the welder. We're going to start with welding one of the old bolts from the old engine on top of it and seeing if we can use that to muscle it out. And it broke immediately. Take two, we're going to try to weld a nut on top, see if we have any better luck with that. I promptly rounded this off and attempted to use vice grips and then made it a perfect cylinder, so fail number 2. So we cut the head off of one of those bolts. That'll allow us to weld a really thick bead under the head of the bolt. And with like a 6-foot breaker bar, broke it loose. It's pretty satisfying to get this thing out. It was only like a minute of video time, but this was a couple hours of my life. Got a nice little memento now. So for the first time in 8 months, we can get this engine off the stand, back onto its little tire seat, and put the clutch and bell housing on. Before we hook anything up, we have to install the clutch pilot bearing. This engine didn't have one in the crankshaft. I think that's because it was hooked up to an automatic transmission before. A clutch pilot bearing centers the input shaft of the transmission and is important for aligning the clutch transmission and back of the crankshaft. It's a pretty tight interference fit. I tried a bunch of different ways of pressing it in. You know, we got to break out the blowtorch whenever we can. I ended up getting a little frustrated and just using a socket and a hammer. Definitely not the right tools to do this, but hey, it worked. Then we can put the flywheel on. It doesn't really press on, but it does sit on a little seat on the crankshaft. So you tap that on, and then there's 6 bolts that hold it in. I did expect this to spin more when I was tightening the bolts down, so maybe we have too much friction in our engine. I guess I'm not aiming for high power, but I think it's supposed to spin freer than this. Torque to spec, just how you guys like it, and then we'll give it a good wipe down with some brake cleaner. We want to make sure there's no dirt or oils on the flywheel. This is what the clutch actually slides up against, so you want to make sure it's just clutch pad on flywheel, no contaminants in between. Then I quizzically study the clutch, because it says this side toward flywheel, but then it just kind of plops into place. I bought a little nylon alignment tool that sits inside the clutch pilot bearing and has splines on the clutch. That helps center it. I think sometimes you do this with the transmission, but my transmission's still on the truck, so a little $6 tool does the job. I think we probably could have 3D printed that, but $6. Then we put the pressure plate on, make sure we clean that too with brake cleaner. This bolts to the flywheel, and so the clutch spins freely in between these two when you have the clutch depressed. But when it's not, this is tightened down against the flywheel, and this is what makes contact between the flywheel and the clutch. If you look closely, you can see the little fingers closing up as I tighten it on. And yeah, I hope we did that right, because this would be a huge pain in the butt to do laying underneath the truck. But somehow people do it. The bell housing goes on pretty easily. It's open on the bottom, so there's no seals or gaskets or anything to worry about. 4 screws. Easy as that. Side note, this clutch fork boot is one of the hardest things to procure on this truck. The guy at the Amazon returns counter at Kohl's looked at me pretty funny when I returned the 2 that didn't fit. And then we can mount the engine. I wish it was as easy as that. The sweat stains on my back should tell you that this was a long and belabored process, a lot of lifting and lowering and figuring out what we were doing wrong in between. Part of the difficulty is that the transmission is disconnected and it's balanced on some jack stands and being held up by straps. We had to maneuver that into place first, mount it to the engine, and then get the engine up on its front and rear engine mounts, which are mounted on top of rubber bushings. Finagling the transmission was the hardest part of this whole build. At one point, I held it up with straps from the engine hoist through the truck's window. There's probably a better way to do this, but I kind of painted myself into this corner and had to get myself out through some creative ways. The other difficult part was getting the front engine mounts to thread in. After 2 days of struggling with this, I finally lifted the engine and supported it with some wooden blocks to figure out that, hey, the new engine mounts use a different size bolt than the old engine mounts did. It's actually smaller, but I think it's okay. They're rubber mounted and bolts are pretty strong. I'm not that worried about it, but yeah, if you try to thread a big bolt into a small hole, you're going to have a bad time. There is a decent amount of play in these rubber bushing mounted engine mounts, so I probably would have had a lot more fun if I used the right bolt from the start. But yeah, getting a 800-pound assembly onto 4 mounting bolts, pretty difficult task. If you remember from the last video or 3 videos ago, I don't remember, the transmission bolts up to the bell housing, and the bell housing mounts to the rear engine mount. So we have the transmission mounted here, but the bell housing mounts won't go through. And it turns out we just needed to clean the threads up on the rear engine mounts. This is a lesson I keep learning on this build. Clean out all the threads before you start reassembling stuff. Otherwise, you don't have to lay on your back like I am here and get cutting fluid and chips all over your face. But once we clean those threads up, all the bolts went in pretty easily, and there we have a mounted engine. Pretty satisfying. But also, it was horrible. So this next part is sort of unnecessary because we didn't have to take any of this stuff apart in the first place, but while we have it apart, let's see how they work. This roller bearing assembly looks pretty clean. This is what allows the U-joint to rotate. The other one was pretty well seized on. The roller bearings are rusted and there's no grease left inside. I guess I'm kind of glad we took this off. That's pretty crusty. I soaked these in degreaser and then packed them full of grease and put them back together. So a quick blast with some engine degreaser and then a brush with a brass bristle brush. And I think we're a lot better off now. I did notice that there is a grease fitting here. So you pump grease into here and then it forces it through the shaft. I don't know if it's blocked up or maybe you're just supposed to grease it more than once every 55 years, but we'll load the cups up with grease, slap them back on, and be good to go. I'm going to try to withhold judgment about how crusty everything is on this drive shaft and rear half of the drivetrain. The point is, everything is greased up nicely and bolted back together. That's what really matters. And now we can actually move the truck because we don't have several hundred pounds of metal just dangling from the bottom of it. Also, I love this creeper. Just being able to roll out from under the truck is very satisfying. Another thing on our to-do list was cleaning up the wiring. I had seen some exposed copper when I was disassembling things, and after I unwrapped the harness, it turns out somebody just wrapped these wires together and then taped over them. I can't believe the truck lasted this long this way. I don't claim to be the world's best solderer, and I'm definitely not an electrical engineer. I did my best. Every joint I took apart was just wire wrapped together. So I took that apart, I soldered each joint, wrapped it in heat shrink, and then wrapped it in electrical tape. I will probably go back and rewire the whole truck at some point. There's really only like 4 wires in the engine bay, but there are a decent amount of wires underneath the dash, some of which are not even connected. And I just hope they don't short. Anyway, that's a future project. I think I'd like to sit down and actually buy some nice automotive connectors and do this right. Some people say you're supposed to solder, some people say you're supposed to crimp. I figure anything is better than what was here before. Speaking of, this cable was black before. I had no idea it was green and light green. And yeah, I think it came out okay. I'm a little worried the electrical tape is going to fall off, but again, it's better than it was before, and that's really all we're trying to do here. The water pump goes on next. This is mechanically driven off of the main pulley. The only other thing to note here is that these bolts go straight through into the coolant passages. So I'll install the pump first just to get everything flush, and then I'll remove each bolt, apply thread sealant to it, and then reinstall to make sure that everything is nice and sealed up. I can't let a whole video go by without a quick paint time lapse. Refinishing this fan was pretty satisfying. Nobody will ever see it, but I know it's there. Then we put the pulleys on the water pump, the fan on after that, and then very important order of operations here. This fan shroud can't be removed when the radiator is in, so we install it kind of hooked around the fan for now. We'll drop the radiator in on top and then mount up the shroud to the radiator. In hindsight, I'm glad I took the whole radiator out. This would have been pretty difficult to maneuver the engine around. Plus, if you damage the fins on the radiator, you either have to straighten them out or you could permanently damage the radiator. So it's probably best to just remove it. It's not that heavy. You have to drain the fluid anyway. Good lesson learned. Quick sidebar on the exhaust manifolds. One of them had these little tubes inside. I'm pretty sure this is an emissions thing. If you remember, the old engine is a 1976 engine, so it does have California CARB regulations to follow. These little bungs move up and down, and I don't know, I read about this. I don't really remember how they work, but they're easy to remove, and again, we are not emissions compliant. Another cool thing about the exhaust is this butterfly valve. This truck is filled with manual controls like this. This is a heat-sensitive spring on the side that opens and closes this valve. When it's cold, it rebounds and closes the valve. If we simulate engine heat with the blowtorch, any excuse to use the blowtorch, you can see that this is slowly opening. So basically, as the engine warms up, it flows more exhaust gases. And then when the engine is cold, it snaps the butterfly valve shut, which forces exhaust into the crossover tube and I think helps the engine warm up faster. I was riding the high of using the blowtorch to show you how the exhaust manifolds work, so I decided to use that on the thermostat too. As this heats up, there's a spring inside that should pop open, and that's what allows coolant to flow into the engine. Until the engine is warmed up, coolant isn't flowing. But unfortunately, we just lit this on fire, so we couldn't see it open, and also now I can't use it. And luckily I had to, so we won't be doing that demo again. I had cleaned the transmission on my to-do list, so this time-lapse is to prove that I at least cleaned the top, because I won't have access to that after I put everything back together. While I was cleaning it, I realized that whatever this sensor is has a broken pin on the side. This sensor is the reverse light indicator. I thought maybe it would be a complex sensor, but the multimeter tells me that this is just a metal ball that makes contact with the leads on the inside. So when you shift it into reverse, it depresses that ball and completes the circuit. I'm glad this was only like $9 because this is in competition for the lowest tech part of the truck. Next to-do list item is filling the transmission fluid. There's a fill port here. I did buy a pump to pump through that fill port, but you can also fill it from the top until it dribbles out from that fill port line, and then you know it's at the right point. That seemed a lot easier. I'm not going to show you the puzzle piece that was the alternator mounting. I had a whole bunch of brackets from the two engines. I cobbled them together, and yeah, it's not going anywhere. Filling up the engine oil is also an adventure. On normal cars, you fill through the intake manifold through like a fill port. No such port exists on this engine, so since the valve covers are off, I just kind of jammed it through one of the holes, and that works. So with no spark plugs or wires on, we know the engine won't start, but we can use the starter motor to turn it over. This checks a couple things. First, that the starter motor is meshed properly. I know that because it didn't make a really terrible noise when I tried to turn the engine over. The second thing is forcing oil through the oil pump and through the various areas of the engine. I should have seen oil pressure when I did this. I didn't. Hopefully we see it when we actually start the engine, or that's going to be really bad. I went over this in a previous video, but next we have to install the spark plugs and the spark plug wires. Each wire is a different length and corresponds to a different cylinder. You have to make sure that you get them in the right order relative to the distributor. I have my handy decoder ring that I drew on a box like a year ago now. The wires are referenced to a semi-arbitrary starting point. You set the engine so that cylinder number 1 is at top dead center. And at that point, the distributor rotor is pointing at the terminal on the distributor that is for cylinder number 1. So here we line it up with cylinder number 1, so we just have an easy way to reference it. And then we set the position of the other wires based on that. So we're finally back where we started this video. Let's see if it'll start. Notice what wasn't on the to-do list from the last video? This is that pump that I bought to fill up the transmission. It did come in handy to prime the fuel pump, and basically want to make sure that we have fuel up to and past the fuel pump. At this point it was late and the battery was starting to sound a little sad, so I threw it on the charger and let cooler heads prevail in the morning. So let's do a quick lesson on how engines work. To get an engine running, besides checking that you have fuel in the fuel tank, that the battery's charged, that the starter motor is engaged, besides the obvious stuff, you have to check for 3 things: compression, fuel, and spark. If you have those 3 things, the engine will turn over and run. It might not run well, but you're putting energy into the system. That energy has to go somewhere, and it goes into physically moving the engine and turning it over. Once you have those 3 things, then it could be carb tuning, timing. If you have fuel injection, it could be a computer problem. But we clearly don't have one of those 3 things, at least, because our engine is not even turning over or trying to start. And let's explain why. So let's start with a drawing of our block, or like our cylinder. That's the inside of the cylinder. We have an exhaust valve. We have an intake valve. We have a spark plug on the side. And then inside of the cylinder, we have a piston. And that piston moves up and down 4 times. So down, up, down, up. Each one of those is a stroke in our 4-stroke engine. So easy way to remember it is suck, squeeze, bang, blow. Fun little mnemonic. Each one of those represents one movement of the engine. So on the first movement, we're going to move down. The piston moves down. It pulls a vacuum, basically, on this open intake valve, and that pulls fuel
and air into the cylinder. So on the way back up, that squeeze, or the compression stroke, it's compressing that fuel-air mixture, which makes it more energy dense and more likely to detonate, deflagrate. Once you have your compressed mixture, then it's the bang stroke. The spark plug fires, ignites that air-fuel mixture, and that explosion or deflagration pushes the piston back down. That's your power stroke. That's what's generating the power and moving the crankshaft and turning the engine. On the upward stroke, the last one, the blow stroke, it's pushing all the exhaust gases up that valve and out of the engine. And so each cylinder, as it's turning over, is doing each one of those motions, and that completes your engine cycle, which makes the engine run. So when we say fuel, compression, and spark, on the intake stroke, you want to make sure that you have fuel coming out of your carburetor going into the intake manifold and into the intake valves. Spark, you want to make sure that your spark plugs are firing. And compression, you want to make sure that when the piston is moving, it's compressing the air. If we check each one of those three things, the engine should run. In our case, I don't have a compression tester because I'm cheap and I don't want to buy one. Also because I know that the engine has compression because we just rebuilt it. When we turned it over, you could hear the air being pushed out of the cylinders. You could feel it with your finger. We know that we don't have any leaks around our cylinder seals, our piston rings. And so that would stop you from having compression. If you didn't have good compression, your air-fuel mixture would kind of slip around your piston, and you wouldn't be generating any compression.
Okay, to be honest, none of that really worked, and I got so frustrated that I just sprayed some brake cleaner in the carb and tried to start it up, and that's what worked. You can tell I didn't think it was going to start because I didn't even have the garage door open. But it was a pretty great moment to finally hear it start. Until it died. I try to grab the throttle and crank it up to keep it alive. That doesn't work. It backfires directly into my face. And then I think the brake cleaner lights on fire. But it started. At this point, I'm feeling pretty good. It was a couple days of trying to get it to start. It starts, and there's no leaking oil, coolant, or fuel. Seems like a big victory. And it was. So the next day, I set out to do some engine timing. It doesn't sound like it's running right. Part of that is the footage from my phone. Part of it is because the timing is still kind of dog shit. I break out the timing light and try to set reasonable timing. That involves revving it up to like 3,000 RPM and seeing how the timing differs. It starts to smoke quite a bit when I'm doing this, and I thought that was maybe just burning off, lubricant or oil from the assembly process. And I didn't really pay it any mind. I did set off the smoke detector a couple times and probably smoke my neighbors out of their house. I end up with pretty reasonable timing, about 30 degrees. And so I grab my Saturn keys to move the car out of the way so I can take it for a spin around the block.
Oh, fuck.
And that's when I noticed the puddle of oil. I didn't catch it on the gauge, but I did still have oil pressure, so it wasn't catastrophic. But we dropped like a quart of oil on the ground. And that's not good. tightening the oil pan was worth a shot.
Oh, I got it in my hair. Oh, fuck. Damn it. Ah, shit. I really hope that's enough, because there's no way I'm going to be able to get our TV up there. Oh, golly. Gotta get some kitty litter. Okay, I may have found the source of the leak. The left hand, I guess right hand head was dripping oil, basically back behind the exhaust. I think that's also why I was smoking so bad. There's 4 screws that hold in the valve cover. The previous owner stripped one of them, retapped it with what I'm pretty sure is a 13 mil thread. This is a bolt from my Saturn Sky that I had an extra of when I replaced the cat. And so I cut it down, and I think maybe it just wasn't fully threaded in. So we're gonna try to reinstall it and see if that fixes it. Fingers crossed, because I might have to pull the engine otherwise. I'm not sure how to redo the oil pan seal in a better way. And discovery number 2, I did check before that this bolt went through the holes for the valve cover. I did not check if it goes through the hole in the gasket, and it doesn't. So I think maybe this was just pushing the gasket out of the way and there was no seal on that back corner. Feeling better. Okay, the next problem was the little bracket wasn't sized to fit the big screw anyway. So I fashioned this little wooden jig to hold it in place, because I almost broke my fingers the first couple times I tried to drill it. I lost my bolt. Good enough.
There was also a pin drop of oil on the timing cover. I tightened it down a little bit, but that didn't seem to help. And so it's not really how our TV is supposed to be used, but I just filled in the crack. Hopefully that holds. It seems like those fixes helped or fixed it entirely. The valve cover leaks were hard to diagnose because they dripped down across the entire engine, and it was hard to tell where it was coming from, but it looks pretty dry. While I was waiting to see if any oil leaked out, I also checked that the alternator was charging. This should be higher than the 12 volt nominal of the battery, so that's good. If you remember the videos from like a year ago, that coolant sensor doesn't actually work, but the thermostat should open at 190 degrees. It's pretty close to that when it's idling, but I don't think idling gets it hot enough to actually open the thermostat. We'll have to do some measurements while it's driving, I guess. And then before we drive around the block, I want to put the air cleaner on so we're not sucking stuff into the engine. And of course it doesn't fit. It's hitting the condenser, the big capacitor that goes on the distributor. They make spacers to solve this exact problem, but I didn't realize they were plastic, and I'm opposed to buying plastic parts when I have a 3D printer. So a quick PLA prototype lets us test the fit, and then we'll actually print the final part in a higher temp plastic. In this case, polycarbonate, which is kind of annoying to print. I don't want to tell you how long I spent watching this web portal waiting for it to finish. It finally finishes, pull it off and do some cleanup. Almost ready to go. For anybody who's worried about a plastic part inside the engine bay, polycarbonate is good up to like 300 degrees Fahrenheit. And again, plastic parts are what you buy at AutoZone. Of course, we go to put it together, and now the top doesn't fit. But we flip it upside down, Edelbrock doesn't get any free advertising, and no one is worse off. You can't actually see that there's a 3D print under here, but that'll be our little secret. And with that, I'm out of reasons to not take it for a spin. I don't want to dox myself by showing the full test drive around my neighborhood, but here's a funny noise it makes when the throttle sticks, and it sticks a lot.
Throttle sticks. But we did it. Back on the road.